Hello, 8th graders. In lesson 3, we're going to be looking at powers of 10. But first, this picture right here, I don't have a picture of my dog this time to start it out, but I have this picture which is pretty relevant to our world right now. And I'm just asking you, what do you notice and what do you wonder? Now, if you send me an email with your answer to those questions, I'll give you 1 bonus point on this video. And just know that your answers may be shared with the class at some point. Okay, here we go. Okay, in this one I drew a picture to help us visualize this cube that has side lengths of 10,000 kilometers. Remember that the volume formula for a cube is length times width times height, and so that's 10,000 times 10,000 times 10,000. Another way to write that would be 10,000 to the 3rd power kilometers. If you multiplied all this out, you would have a number with 1 and then 12 zeros. Right there. And there you go. That's a really big number. In this lesson, we are going to be seeing some really big numbers and how to use exponents to help us work with them. Okay, we have a table here that we're going to work with to find some patterns with our exponents. This time we are taking powers to another power. So here I have 10 to the 3rd squared. So what's happening here is 10 times 10 times 10. That's 10 to the 3rd. And I'm taking that times itself right there, another 10 to the 3rd. So there's my 10 to the 3rd times itself 2 times. And if I count up how many times 10 is really being multiplied by itself, after I expand that out, I get 6. So I could rewrite this as 10 to the 6th power. Down in our next one, we have 10 times 10, that's 10 squared. And that's being multiplied by itself 5 times. So 1, 2, 3, 4, 5 times. And if I count up how many times 10 is being multiplied by itself in the expanded form, it's 10 times. So that would be the same as writing 10 to the 10th power. In the next line, I can see in parentheses, I have 10 times 10 times 10. So that is 10 to the 3rd power. And I have how many of those being multiplied together? 4 of them. And if I count up how many times 10 is being multiplied together in the expanded form, I would notice that there's 12 of them. So I could rewrite that as 10 to the 12th. I want you guys to go ahead and finish the last 2 parts of the table and answer B and start again when you're ready. Okay, here's your finished table. And notice I have 10 to the 4th being multiplied by itself 2 times, and I have a total of 8 10s being multiplied together. So it's 10 to the 8th power. I did not want to do this last entry. That's the one I skipped, but I did notice a pattern. I noticed that I'm multiplying my exponents to get my simplified exponent over there. So 8 times 11 is 88. So this is the same as 10 to the 88th power. In number 2, using the patterns we just saw, we saw that we would need to multiply our exponents. So I could rewrite this as 10 to the m times n power. In number 3, I drew the cube for us with each side being 10 to the 3rd meters long, and volume is length times width times height. I could rewrite this as 10 to the 3rd to the 3rd power. And we just saw using rules of exponents, I could rewrite that as 10 to the 9th cubic meters. And if I wrote that out, that would be 1 with 9 zeros. And this would be enough to fill a large lake. In this problem here, Andre is the one who is correct. When you're multiplying those exponents there, we saw in an earlier lesson that you would add those exponents. And so 2 plus 2 plus 2 is 6. Elena did this first step right. You can do that. You could write 10 squared to the 3rd power because that's what's happening there. 10 squared is being multiplied by itself 3 times. But we just saw that when you take a power to a power, you need to multiply those exponents, not add. So this is the step where she made the mistake. Okay, to wrap this up, take some notes here on this page. Earlier, we saw that when you multiply with exponents, you would add those exponents together. So I could rewrite this as 10 to the 12th power by adding 4 plus 4 plus 4. Now we just saw that when you take a power to a power, you end up multiplying the exponents. So I could rewrite this as 10 to the 12th as well, because 4 times 3 is 12. In lesson 4 here, we're going to be dividing with powers of 10. So here we go. Okay, if you evaluate this one, If I just do each of the exponents, this is what I have. And if I simplify that, my numerator would be 23,328, and my denominator would be the same thing. And this would all simplify to 1. And in this lesson, once we figure out some rules with dividing with exponents, you'll see why that works. Okay, here we have a table working with dividing with exponents. Your book does this slightly different than I would, so we're going to talk through things a little bit here. First thing, 10 to the 4th divided by 10 squared. That's what we have right here. We have 10 to the 4th divided by 10 squared. And I'm going to simplify this because I know that 10 divided by 10 is 1. So there's 10 divided by 10, that's 1. I could do that again. 10 divided by 10 is 1. And what I'm left with is, in the numerator, 10 times 10. Here's the part that I'm just going to skip in the book. And then we get to what we have left. And we notice we have 1, because 1 times 1 right here is 1. And then times 10 times 10. And I could simplify this as just 10 squared. Okay, in the next line, I'm looking at what I'm starting with here, and I notice I have 10 to the 5th being divided by 10 squared. And I'm going to simplify that. 10 divided by 10 is 1. I could do it again. 10 divided by 10 is 1. And I'm left with 10 to the 3rd right there. I'm going to skip what they did in the middle, and you can see right here that it's the same as 10 to the 3rd. I want you to finish up the last 2 rows of the table, answer question B, and start again when you're ready. In the next row here, or these are what your last 2 rows should end up looking like. 10 to the 6th divided by 10 to the 3rd. Again, I could simplify that. 10 divided by 10 is 1. 10 divided by 10 is 1. And again, and what I'm left with is 10 to the 3rd power. Now, I did not want to write out 47 tens being multiplied together down here, but I did notice a pattern. I noticed that if I subtract my exponents, that ends up being the exponent that I'm left with. And so 43 minus 17 is 26, so this is the same as 10 to the 26th power. On number 2 here, using the rules we just saw, we would subtract those exponents, so this would be the same as 10 to the n minus m power. And just be careful there, the order does matter. It does need to be the exponent in the numerator minus the exponent in the denominator. In number 3, if I'm going to figure out how many trees per person there is, I'm going to subtract my exponents, and this would be 10 to the 2nd, or 100 trees per person. Okay, so reviewing our exponent rules, in number 1, this would end up being just 10 to the 12th if I added those exponents. And in number 2, this would be 10 to the 8th if I subtracted those exponents. And in part A, for both questions, what number could you multiply 10 to the 12th by to get this same answer? Well, that would have to be 1, and the same thing goes down here. To get the same answer there, I would have to divide by 1. Going on to number 3, to make those exponent rules work that we just saw, 10 to the 0 power has to be 1. And we'll be working with that more later, so if it's not making sense, just hang on. We are going to skip number 4, so don't worry about that one. I want you to take just one note here. We're just going to talk about this first bullet point. How can we write this using a single exponent? Well, I'm going to subtract my exponents. So it'd be 10 to the, well, 36 minus 12 is 24. So 10 to the 24th power.